All right, so we're going to change gears just a bit, and we'll come back to the differentials, but let's go find the nth derivative. So that means I need to establish a pattern for these derivatives. So let's just start by writing the first function down, e to the 5x. And then what happens when I take one derivative? I get e to the 5x times 5 using chain rule. So I'm going to pull that 5 out in the front. And then when I take the second derivative, I carry this 5. And I take the derivative of e to the 5x, and I get e to the 5x times 5, chain rule. So I get 5 squared. Remember, when we're establishing a pattern, you don't want to multiply your numbers together. So the third derivative will be 5 squared e to the 5x times 5. I think we get it. I think we see the pattern. All right, so if I want to find what the nth derivative is, it's going to be 5 to the nth power e to the 5x. All right, so let's try one that's a little more challenging. Okay, here we go. So this function here, before I go take a derivative, I'm going to rewrite it as x to the negative 1. When I'm taking many derivatives, I'm never going to use quotient rule. I'm going to always rewrite it as to powers. All right, so here we go. One derivative. Negative x to the negative 2. Two derivatives. The two negatives cancel, so I get a positive x to the negative 3. Third derivative, so I get a negative 3 times a 2. Again, do not multiply the numbers together. X to the negative 4. Four derivatives usually gives you a good indication of what's happening. So this comes down, so I get a 4 times a 3 times a 2, x to the negative 5. All right, so let's think about it. I'm positive you've seen numbers like this before. Don't you know that 4 factorial is 4 times 3 times 2 times 1? All right, so let's do it. So the nth derivative, so I see three things going on. First, I see a factorial. Second, I see x to some number up here, right? We'll have to figure out what that is. And third thing is I see that it's changing signs. So I see that it's changing from positive to negative. All right, let's start with an easy one first. Let's do the factorial. So the factorial, I think, looking at it, I think it's n factorial. So factorial is always a positive number, so we can't include the negative. So there's n factorial there for the nth derivative. All right, so let's work on the x to the power. So I see x to the negative, and you get to choose how you do this, but I'm going to say one more than the derivative. So I'm going to factor that negative out and say that opposite of one more than the derivative, negative n plus 1. All right, so now let's do this changing sign thing. What I'm going to suggest is that you just try negative 1 to the n. So if I put down negative 1 to the n, does it work? So when I'm doing the fourth derivative and I put n equal 4 in, does it work? Does it make it positive? It does. Check more than one so you make sure you don't make a mistake. If I put a 3 in here, it makes it negative. That works. If this doesn't work, the other one will, of n plus 1 power. So choose one, and if it doesn't work, go to the next one. All right, let's do these next couple. So again, don't do quotient rule. Rewrite it so that you can do chain rule. Don't do quotient rule a bunch of times. Way too cumbersome, and you will not be able to see a pattern. So I get negative 1 minus x to the negative 2 times negative 1, chain rule, fix the negatives. So if I fix these two negatives, correct, if I take this negative and put them together, they make a positive. So I guess get that. All right, second derivative. So this negative 2 comes down, 1 minus x to the negative 3. Just take the derivative of the inside, negative 1. Fix the negatives. Those two negatives there make a positive. So I get 1 minus x to the negative 3. All right, third derivative. Bring the negative, whoops, I dropped my 2. Here we go, so the positive, but I forgot the 2. So now I bring this down, so I have a negative 3 times the 2 1 minus x to the negative 4 power times the negative 1. Again, fix the negatives. Okay. So I think I see a pattern. So let's see if we can do it. So let's check out the number of things I see. So I see 1, I see a factorial again growing. 2, I see there's a 1 minus x to a number, a power. And the third thing, there's no third thing, right? It's always positive. It's not changing sign like the last example I did. So I don't need to really worry about that. So the factorial, I think, is going to be n minus 1 factorial. And then I'm going to have 1 minus x to the negative n plus 1 derivative. All right, let's just finish this last one up. So the function will be 1 plus x to the negative 1 power. So negative 1 plus x to the negative 2. So this 2 negatives make a positive. Third derivative, negative 3 times 2. And then fourth derivative, so 4 times 3 times 2. Okay, so this one does have 3 things going on. So let's go do it. So I like to take care of the easy things first. So I think it's n factorial. I can see that it's got a factor of 1 plus x to the negative, and it's 1 more than the derivative. So now let's deal with this in front here. What do I have? It's changing signs, so I'm going to try negative 1 to the n. And if I put negative 1 to the n, if I put 4 in there, is it positive? Yes. If I put 3 in there, is it negative? Yes. So that works.